G'day. What we're looking at today is we're looking at CIS properties. Last lesson we looked at calculating from Cartesian to CIS. What we're going to be doing now is we're going to be using those CIS properties to help us calculate different types of radian functions. Now last lesson I did say that CIS is much easier to handle than it does come to Cartesian. So there are three main properties when it comes to CIS properties. The first one is if we have CIS theta times CIS phi, it's the same as doing CIS and adding your two arguments. So in this case, it's CIS theta plus phi. The second rule is CIS theta divided by CIS phi is the same as just subtracting theta and phi away from each other. So very, very similar to your log rules that you've learnt before. The last one is a little bit out there. I'll explain how it works. It's basically if we have some angle of CIS and it's beyond the recollection. So remember we have boundaries of our arguments. Now arguments boundaries are negative pi to pi. This may be beyond our boundary. So what we do here is we say, okay, well we want to find some value that we can multiply it by 2 pi, that essentially what it will do is just bring us back to the original. So what it will do here is it will just cancel out what we have here. So we're just dealing with something that will fit within our correction parts. So our restrictions of negative pi to pi. So for instance, if we had, let's say we had 91 pi over 3. The first thing we do here is we're going to ask ourselves, how many times does the 3 go into 91? Well, we know it goes in 30 times with 1/3 remaining. So we ask ourselves here, what could we multiply by 2 pi to give me to 30? And that answer here would be 2 times 15 pi. So 2 times 15 pi essentially cancels out that 30 pi here, and I'm just left with 1/3 pi. So therefore, that becomes my angle that I use when I'm calculating for CIS. And that's how that works. So basically, if we're looking at this here, we're starting at, say, 1/3, we're going to go around 15 times essentially, until we get back to where we're going, so we know that this here is that's left over. So the whole idea behind this last rule here is to find something that we can use to cancel out that leaves us with the remainder to be able to calculate. So I've got some examples up here. Let's do a couple of these, 3 of these examples together. We've got CIS pi on 5 times CIS 3 pi on 10, CIS 5 on pi on 5, CIS 7 pi on 10, and 107 pi on 6. Let's do the first one here. So we've got CIS pi on 5 times CIS 3 pi on 10. So first thing we need to do here is we're going to use our rule. And our rule states if we're multiplying, we're going to add these two arguments together. So therefore, we get CIS pi on 5 plus 3 pi on 10. And we're going to write a little note over here as CIS theta times CIS phi is equal to CIS theta plus phi. Really important that we put that information in because it's telling the marker what we've done. Alright, this just then comes down to our basic understanding of fractions. We need to make sure that we get the same denominator. So in this case, I've got 10 here, I just have to multiply this here by 2. So if I multiply this side by 2, I end up with CIS 2 pi plus 3 pi all over 10. Which then gives me cis 5 pi on 10, and we can simplify it down. We can cut the 5 out, gives us 1, cut the 10 out, gives us 2, so therefore cis pi on 2. So once we get cis pi on 2, we haven't finished yet, because what we're doing here is we want to break this down to get our Cartesian point. What is cis pi on 2 equal to? So we now expand cis. Now remember what cis stood for? Cosine pi on 2 plus I sine pi on 2. So if we look at the unit circle, let's look at the unit circle up here again. Here we've got cosine, sine. So if we look over here, x is 1, y is 0. Here x is 0, y is 1. Here x is negative 1, y is 0. And here y is negative 1, and this here is 0. We want pi on 2. Pi on 2 is this point here. So we then work out that if we then change this, we get cis times 0 plus I sine times 1. Well, this here then equals I. So we'll do 0. 0 plus I, so therefore our answer is I. So cis pi on 5 times cis 3 pi on 10, when we work it out and simplify it, we then put it into the expanded form of cis, use our understanding of the unit circle in terms of its connection points, or plug those in, and we end up with I. All right, let's have a look at the second example now. So our second example is cis pi on 5 over cis 7 pi on 10. All right, so we're looking at this second example over here now. So therefore, cis pi on 5 minus 7 pi on 10. Our little statement here as cis theta over cis phi is equal to cis theta minus phi. Alright, so we've got this here. Same thing as we did in the last lesson. The last question was, we're going to use those kind of fraction understandings. So we go cis, what can I do to make this here 10? I can multiply everything by 2. So I get 2 pi on 10 minus 7 pi on 10. I'm going to get a negative answer, which is fine. Okay, so therefore I get cis is equal to 2 take away 7 is negative pi on 10, which I can simplify down to cis is equal to negative pi on 2. So when we look at the unit circle again, and we'll do this just here again, remember we've got 1, 0, 0, 1, negative 1, 0, and negative 1 and 0.